Hey folks, Miss DeMayo here. I'm just going to be going over our redox test. Hopefully this helps you. Alright, so number 1, what is the oxidation number of sulfur in Na2S2O3? So the first thing to notice about this problem is we're trying to figure out the oxidation number of sulfur, so that's our unknown. And we know that compounds have to be neutral, so the charges of all these elements must add up to 0. Now, I have rules about sodium and oxygen. You use your reference table for that. So oxygen has a charge of -2. Sodium has a charge of +1. I have 2 sodiums, so altogether that's a +2, right? Because 2 times +1. Plus, here's the tricky part. There's actually 2 sulfurs because of that subscript 2. So 2x plus, actually, -2 times 3 is going to be -6, right? And that's all equal to 0. So if we rearrange this equation, it would be 2x minus 4 is equal to 0. Then it would be 2x is equal to 4, and x would be equal to +2. The correct answer is B. So if you put if you put choice 4, you probably didn't realize that there's that subscript 2. Which change occurs at the anode in operating an electrochemical cell? Okay, at the anode, you should remember anox. Oxidation always occurs at the anode. What does oxidation mean? It's the loss of electrons. And you remember that by doing Leo-Ger. So oxidation is loss of electrons, choice 4. What occurs when chromium ions are reduced to chromium ions, but chromium 3+ to 2+? So you should notice that that's going down on the number line. So that's reduction. And reduction is Leo-Ger, the gain of electrons. So you can eliminate choices 1 and 2. Electrons are gained and the oxidation number increases. No, it's actually not that, right? Because the oxidation number decreases. And this is really hard for people, and this is because when you're gaining a negative electron, it actually makes the charge go down. Even though it feels like it should be reducing, feels like it should be losing, it's actually gaining. Given the balanced ionic equation, which half reaction represents the reduction that occurs? So you need to look at this reaction. We can pull 2 half reactions out of this reaction. Aluminum to aluminum, copper to copper, we connect them. Aluminum's going from 0 to +3, so it's going up. So that's Leo. What's up, Leo? +2 to 0, this is going down, Ger. So what's happening is that aluminum is losing 3 electrons and copper is gaining 2 electrons. They want to know the reduction half reaction, so I'm focused on copper. And reduction is gaining electrons, so electrons should be a reactant, and the only choice that does that is choice 4. Given the balanced equation representing a reaction, what is the total number of moles of electrons lost by Mg when 2 moles are gained by Ni? So this question might be a little bit confusing to you, but really all you have to remember is that in a redox reaction, it's always the same electrons that we're talking about, right? So if 2 moles are lost by the magnesium, then 2 moles must be gained by nickel. That's it. Which balance equation represents a redox reaction? Number 6. You should remember that a reaction that is never redox is the double replacement reactions. So hopefully you remember your types of reactions. Double replacement reactions are never redox. If you remember that, then you can eliminate choices 3 and 4. And to see a redox reaction, right, we need to see oxidation numbers changing. So let's go ahead and define oxidation numbers for our remaining 2 choices. This is a free element, so it has a charge of 0. This is a free element, so it has a charge of 0. And this is diatomic Hankelbrief, right? For this compound to be neutral, magnesium is in group 2. I know it has a charge of +2. I can check my reference table to confirm that. And chlorine has a charge of -1 then, because there's 2 of them. So clearly the charge has changed from reactants to products, so yes, this is redox. If we checked it for these, +2 -2, +1 -2, +2 -2, +1. In order for everything to be neutral, the charges do not change from reactant to product side, as you can see for choice B, or choice 2. When a voltaic cell operates, ions move through the salt bridge. So electrons never move through the salt bridge, only ions, and that's what keeps the half cells neutral and completes the circuit. If we didn't have the salt bridge, the battery would not work. This is a picture of an electrolytic cell, and that's actually what the question is asking you. But you should know that because there is a battery or a power source pictured here. And you should also realize that because there is one cell or one beaker. Voltaic cell always has 2. So this is an electrolytic cell. And then you have to remember what happens in an electrolytic cell. The electrolytic cell needs the battery in order for the reaction to go. This reaction would not happen on its own. It would not be spontaneous. So an electrolytic cell converts takes electrical energy to produce a chemical change. Which ion is most easily reduced? A lot of people struggled with this question too, number 9. So for this question, we're going to need to use table J. Table J is, if you look to our right, table J is the activity series, so it tells you the most active and the least active elements we have. Now, if you remember, the most active metals are the ones that want to be oxidized. But this question is asking us for which ion is most easily reduced. Most easily reduced is going to be the one that's least active. So a lot of people picked the most active one. So the ones that are least active are towards the bottom. So we're looking for the one that's closest to the bottom. And if we picked that, that would be cobalt. You just have to look through each thing. Alright, number 10. Based on table J, which ionic equation represents a spontaneous reaction that could occur in a voltaic cell? So, we just talked about table J. Spontaneous reactions only occur in a voltaic cell, and that would be where the metal that is being oxidized is above the metal that's being reduced on table J. So thankfully we only have iron and magnesium. So we only have 2 options. So let's look at table J and try to find those 2. Magnesium and iron. I found both of them, and it looks like magnesium is above it. Magnesium then would be oxidized, and iron would be reduced in order for this reaction to be spontaneous. So I'm trying to find the equation that does that. Oxidation, what's up, Leo? Reduction would be down. So I'm trying to see magnesium's oxidation numbers go up from left to right, and I'm trying to see iron's oxidation numbers go down from left to right. So choice 1, 0 going to +2, iron's going up. That's wrong. Fe0 to Fe +2, iron's going up. That's wrong. Fe2 plus to Fe0. Okay, iron's going down. So let's check out magnesium. Mg +2 to Mg0 in choice 3. So that's going down, right? Again, we don't need 2 that are going down. It is choice 4. We can double check that. Fe +2 to Fe0. That's going down, and Mg0 to Mg +2, that's going up. Just like we said. Alright, that was a lot of work for 1. Question 11, given the balanced equation, in this reaction, each Ni atom does what? So, to determine that, I look at oxidation numbers. Nickel has a charge of 0 here. It's a free element, but in this compound, it has a charge of +2. So what happened to it? It went up, Leo. So it was losing electrons oxidized. How many electrons did it lose? Well, it has a charge of +2, so it must have lost 2 electrons. Which energy change occurs in a voltaic cell? Voltaic cell is a battery, it's spontaneous, it takes a chemical reaction to produce electricity. That is choice 1. Question 13 is a question that got a lot of people, so I'm going to focus on that again. This is just determining the oxidation number. But the trickiest thing about this question for everybody was the charge here. So chromium, or chromate, it says the word ion. It's a polyatomic ion that we can actually find in table E. Here it is all the way at the top. CrO42 minus. So instead of this compound being equal to 0, it's actually equal to -2. Or 2 minus, doesn't matter. So they wanted us to find the oxidation number of chromium, that's my X. And I know the rule for oxygen is -2. So this just turns into a solve for X. X and 4 times a -2, right, this is what I'm doing, is equal to -2. So X is equal to jumping too fast. X minus 8 equal to -2. Rearrange this, and you will get X is equal to +6. Choice 1. So a lot of people picked 4 because 4 would be setting it equal to 0, but that has a charge, right? So you gotta slow down and make sure you're doing the questions slow. When comparing voltaic cells to electrolytic cells, oxidation and reduction occur at the same places. Anox, red cat. Oxidation occurs at the anode, reduction occurs at the cathode. So oxidation will occur at the anode in both types of cells. It's the same for both. Question 15 shows a voltaic cell. Which phrase describes the direction of electron flow? So to figure out what's happening, we always know that electrons flow anode to cathode. Think about that song. We start at the anode, electrons are lost there, right? We always go anode to cathode in both cells. So just all I have to do is I have to figure out which is the anode and which is the cathode. The picture doesn't really help me, but this reaction helps me a whole lot. To find my oxidation numbers that aren't listed, magnesium is going from 0 to +2. What's happening? It's going up. Nickel is going down. Just like we did in the last question. Anox, red cat. So which is the anode and which is the cathode? The anode is where oxidation is occurring. What's up, Leo? Oxidation. So magnesium is the anode. And that means nickel, we're always talking about the solids, right? It's going, these ions are turning into neutral nickel, and it's growing, right? The fat cat. So this side is growing and this side is being eaten away. This must be the cathode, because reduction is happening to nickel because the oxidation number is going down. So electrons are going to flow anode to cathode. They're going to flow Mg to Ni. We're always talking about the metals. That's why we didn't pick the ions in solution. Given the reaction for the corrosion of aluminum, which half reaction correctly represents the oxidation that occurs? Define oxidation numbers. Aluminum and oxygen are both free elements. And in this compound here, aluminum is +3, oxygen is -2. Just pull that right from the periodic table. So aluminum is going from 0 to +3. That's going up. Oxygen is going down. You always have to have one being oxidized and one's being reduced. Which one's being oxidized? What's up, Leo? It's the aluminum that is being oxidized. So I'm looking for the equations talking about aluminum, which is not choices 3 and 4. And oxidation means losing electrons. Electrons are a product. They're being lost. Just like energy is being lost in an exothermic reaction, or it's being released on the product side. Same thing going on here. All right, end of multiple choice. Now we're on to the part 2 questions. Everyone got number 17, so I'm going to skip over that, but remember, voltaic cell always converts chemical energy into electrical energy. Remember that when you're doing these questions, right, sometimes it's paying attention, like this diagram pays attention to these 4 questions. Make sure that you're looking out for that. And make sure that you're paying attention to everything they tell you. Sometimes they give you a little reading, right? So I'm looking at all parts of this picture to help me. Maybe sometimes I need it to tell me, maybe sometimes I do not. Question 18 says, state the purpose of the salt bridge in completing the circuit. So this was just basic memorization. The picture really isn't going to help you for this. It does label the salt bridge for you. The salt bridge connects the 2 half cells. What's the purpose, though? Is it maintains neutral half cells, but the main purpose of it is it allows the flow of ions, not electrons. Electrons only flow through the wire. Electrons do not go through the salt bridge, only ions. Identify one metal from table J that's more easily oxidized than copper and less easily oxidized than iron. So I need table J to help me with this. So I'm looking for more easily oxidized than copper and less easily oxidized than iron. So I'm trying to find copper and iron on my table. Iron and copper, I see both of them. Iron is above copper. And what are the metals in between? We have cobalt, nickel, tin, SN, lead, and then we also have hydrogen. Okay, so one metal. It wants one metal in between those 2. That means it would be more easily oxidized than copper because it would be above copper, but less easily oxidized than iron. So any of these metals would have been an acceptable answer. Cobalt, nickel, tin, or lead. Hydrogen's not a metal, so that's not one of the options. So any of those 4 options would get you the correct answer. Didn't need the picture for this question either, right? Just need a table J. Now, question 20. Finally something it looks like where we need the picture. Write the balanced equation for the half reaction that occurs in the copper half cell. So the copper half cell, that's going to be the one that has the copper electrode. That's how I know which one it is. It wants the half reaction that occurs in the copper half cell. So that's having to do with copper ions. And you should really look at the equation that they give you, right? You don't need to write it yourself. They give you the equation, and we're paying attention to the copper. So I'm going to connect my 2 coppers to find oxidation numbers. So copper 2+, that's actually the ion that's in solution, just for clarification. All those ions are floating around from being this copper nitrate solution. And then the copper ions are being converted into copper atoms, Cu0, as they gain 2 electrons. And those 2 electrons are coming from the wire. And that's where they're being gained. And then this is what's causing this to grow, the fat cat. I know it's reduction because the oxidation number is going down. All right, so that was a little bit of background. But all they wanted for me was to write the half reaction. I figured out that copper is being reduced from the equation. And I'm just pulling the stuff from this equation and down here to question 20. My reactant Cu plus 2 is being reduced, so it's gaining electrons. How many electrons? Well, the product Cu0, right, has a charge of 0, going from +2 to 0. Half reactions have to be balanced by mass and charge, right? So Now the charge on my reactant side is 0, and that's the charge on my product side. That's the equation you should get for 20. All right. 21 through 24 are based on this reading and this table. During a laboratory activity, appropriate safety equipment was used and safety procedures were followed. A student investigated the relative chemical activity of 4 metals by placing one piece of each metal in aqueous nitrate solutions of each of the 4 metals. The observations from the following investigation are shown in the table. So we have this table that kind of just summarizes the investigation. What this means is if I have a piece of copper, right, this is a description of the metal, it's red, and I place it in copper nitrate, nothing happens to it. However, if I place it in silver nitrate, some black solid appears. So it's just telling what happens when you react wherever these two columns intersect. The student, don't forget about this little paragraph underneath. The student wanted to use information from this investigation to make an operating voltaic cell using a zinc electrode and one of the half cells. So they already have zinc as one of their electrodes. They want a voltaic cell, and they're trying to pick another metal, one of these metals, as the other side. Obviously, they can't pick zinc, right, because they already have zinc. So one of those 3 other options, copper, magnesium, or silver. Write a balanced half reaction for the oxidation of the zinc during this investigation. Well, guys, this question stumped a lot of people. It doesn't really matter about the investigation again, as long as you are paying attention to what they're saying. And what they're saying is the half reaction for the oxidation of zinc. So, zinc. How do I figure out how to start with that? Well, I know oxidation means losing electrons, and I know what's up, Leo, so I know the oxidation number must be going up. Now, to figure out what exactly is happening, I'm going to go to my periodic table, and I'm going to find zinc. So I can find the charge of zinc, or the charge that zinc normally gets. And I can find it right here, group 12, period 3. Oh, no, sorry, period 4. Zinc, right here. Notice in its top corner, it has a charge of +2. And if you really did want to verify, we have this compound here, zinc nitrate, which is one part of his voltaic cell, his or her voltaic cell. And you can assign zinc with an oxidation number of +2 because the nitrate ion has a charge of -1. So I know the charge of zinc is going to be +2, but it's oxidation. So oxidation is lose electrons. So we're going from neutral zinc. It's turning into zinc 2+ or +2. It's losing how many electrons? 2 electrons because it must be balanced by mass and charge. That's it. Determine the oxidation state of nitrogen in the silver nitrate solution. Most people got this one, I believe. So this is making compound neutral. There was no exceptions with this one. They wanted nitrogen. Nitrogen, we don't know its charge. I do have a rule about oxygen. Oxygen has a charge of -2. And silver, check your reference table, guys. Silver's right here, charge of +1. So it's +1 plus X plus there's 3 oxygens, and they each have a charge of -2 is equal to 0. So if we simplify this equation, it becomes X +1 and a -6. That becomes a -5 is equal to 0. So X is +5. That's the charge of the nitrogen, +5. 23, identify the most active metal and the least active metal used in this investigation. So you can get this from using the observations, or you can get this from just using table J, right? Let's use table J. So whenever we're talking about active, we're going to go look at table J. We want the most active metal. and the least. A lot of people only did one, like they only did most active rather than doing both. So make sure that you're reading slowly, right? Take your time on what the question's asking you before you consider yourself done. And it says use in this investigation. So you have to use ones that are used in this investigation. Which ones were used? We labeled them here on the side. Copper, magnesium, zinc, and silver. So the most active one, we're going to look at table J. We're going to look to try to find all 4 of these metals. Copper is very low, so that one might be the least active metal. What's next? Magnesium is up on the top. Zinc is below magnesium. Okay, so magnesium is still the highest. Silver. Oh, silver's all the way at the bottom. Okay, so it looks like magnesium is the most active and the least active would be silver. Identify a metal in this investigation that could be used as the cathode and the other half cell the students will take. So this question stumped a lot of people. So what's important here, sorry, I'm getting a little sore from talking so much. What's going on in here is that we were already told that they're using a zinc electrode. And they want the one used as the cathode. So that means zinc is the anode. So to make it an operating voltaic cell, I need my cathode to be lower than zinc on table G. And it says, again, used in this investigation. I have these 4 options. Again, so zinc is my anode. Which one is my cathode? It just has to be the one that's below zinc. If I find zinc on table J, I actually find copper and silver below zinc. So you could have answered copper or silver. Both are correct. And the last question, 25. Make sure you read everything. When a solid copper is placed in aqueous silver nitrate solution, a reaction occurs as represented by the equation below. Based on table J, state why copper reacts spontaneously with Ag+. Key terms here, react spontaneously. It also tells you table J as a big hint. So why does copper react spontaneously with Ag? Well, if we look at the table here, we're looking for copper and silver. They're right here on the bottom. Silver is the least active and copper is the most active out of these 2. So why is it spontaneous? It's because that copper is more active than silver. That's it. And I can confirm copper is being oxidized because it's going from 0 to +2, and silver is being reduced. So yes, copper is being oxidized, and yes, it is above Ag, and yes, the reaction is spontaneous. Copper is more active than silver, and that's the reason why. Alright, so hopefully this cleared up any misconceptions you had about the test. Thanks for watching.